Ground fault circuit interrupters, or GFCIs, are not designed to function as overcurrent devices. They detect ground faults, which is an imbalance between the current flowing out and the current flowing back in through the circuit. When this imbalance exceeds a certain threshold, the GFCI trips, cutting off the power. Overcurrent conditions, which involve excessive current flow due to a short circuit or a high power draw, are typically handled by circuit breakers, not GFCIs. Circuit breakers are specifically designed to protect against overcurrent situations, while GFCIs are designed to protect against ground faults. GFCIs can sometimes trip due to minor fluctuations in electrical current, especially when multiple appliances are running simultaneously. This is often referred to as nuisance tripping. Nuisance tripping can be caused by several factors. Firstly, faulty appliances can introduce small ground faults that, while not dangerous enough to cause a major problem, can still trigger the GFCI. Secondly, poor electrical connections, such as loose wiring, can also create imbalances that lead to nuisance tripping. Thirdly, some sensitive electronics can generate electrical noise or fluctuations that interfere with the GFCI's operation. If the toaster or coffee maker's internal wiring is damaged, it could cause a ground fault, leading the GFCI to trip. It is important to inspect the cords and plugs of both appliances for any visible damage, such as fraying, cracks, or exposed wires. If you find any damage, the appliance should be repaired or replaced. Running both appliances simultaneously may exceed the maximum power capacity of the GFCI circuit. Toasters and coffee makers are known to draw a significant amount of current. You should check the current ratings of both appliances, which are usually listed on a label on the appliance itself. Also, check the amp rating of the GFCI to ensure that it can handle the combined current draw of the two appliances. To troubleshoot the issue of the GFCI tripping, follow these steps. 1. Test the appliances individually. Plug each appliance into a different outlet or circuit to see if it trips the GFCI. If an appliance trips the GFCI when plugged into a different circuit, that appliance may need to be replaced or repaired. 2. Check the electrical connections. Ensure that all electrical connections related to the GFCI outlet are tight and secure. Loose connections can cause ground faults. 3. Reset the GFCI and try again. After inspecting the appliances and electrical connections, reset the GFCI and try running both appliances together again. If it still trips, it may be due to a nuisance tripping issue or an underlying problem with the circuit. If the GFCI continues to experience nuisance tripping, consider these options. 1. Replace the GFCI. Installing a high-quality or commercial-grade GFCI may be less prone to nuisance tripping. These GFCIs are designed to be more robust and less sensitive to minor fluctuations. 2. Install a surge protector. A surge protector can help filter out minor electrical fluctuations that may trigger the GFCI. This can reduce the likelihood of nuisance tripping. 3. Use dedicated outlets. Dedicate separate circuits for high-power appliances like toasters and coffee makers to avoid sharing a circuit with other electronics. This can help prevent overloading the circuit and minimize the risk of tripping the GFCI. When dealing with electrical issues, it's always a good idea to prioritize safety. If you're not comfortable working with electricity, consider consulting a qualified electrician. They can help diagnose and resolve the problem safely and effectively. Electrical issues can be complex, and it's important to take the necessary precautions to avoid injury or property damage. Electrical systems are designed to operate within specific parameters, and exceeding those limits can lead to problems. It is important to respect electrical safety guidelines to ensure that your home and appliances are safe. Consider how the age of the GFCI might impact its performance. Over time, GFCIs can degrade, especially if they have tripped frequently. The internal components may become less sensitive or more prone to nuisance tripping. If the GFCI is several years old and you're experiencing frequent issues, it might be time to replace it, even if it seems to be functioning. It's generally recommended to replace GFCIs every 10 years or so, or sooner if you notice problems. Another factor to consider is the presence of other appliances or devices on the same circuit as the toaster and coffee maker. Even if the toaster and coffee maker don't exceed the circuit's capacity on their own, other devices drawing power simultaneously could push a circuit over its limit. Look at what other appliances are in use at the same time and try to minimize the number of devices running on the same circuit. If possible, move some of those devices to a different circuit to reduce the load in the GFCI protected circuit. Furthermore, examine the type of wiring used in the circuit. Older homes might have wiring that is not up to current standards. This can lead to voltage drops or other electrical issues that could contribute to GFCI tripping. If you suspect that the wiring is outdated or inadequate, have it inspected by an electrician. Upgrading the wiring can improve the overall performance of the electrical system and reduce the risk of problems. Also, think about the type of GFCI outlet that is installed. There are different types of GFCIs, some of which are designed for specific applications. For example, there are weather-resistant GFCIs for outdoor use and tamper-resistant GFCIs for homes with children. Make sure that the GFCI outlet you are using is appropriate for the location and the intended use. If you are using an indoor GFCI outlet in a damp or humid environment, it could be more prone to tripping. If you have identified nuisance tripping as a likely cause, you might consider using a GFCI outlet with a higher trip threshold. Standard GFCIs trip at around 5 mA. However, there are GFCIs available with a trip threshold of 10 mA or higher. These GFCIs are less sensitive to minor fluctuations and may be less likely to experience nuisance tripping. However, it's important to note that these GFCIs provide less protection against ground faults, so it's crucial to weigh the pros and cons before making a decision. You should ensure that using a GFCI with a higher trip threshold still meets all applicable safety codes and regulations. Another potential issue is a shared neutral wire. In some older homes, multiple circuits may share a single neutral wire. This can cause problems if the current in the neutral wire becomes excessive, leading to voltage imbalances and GFCI tripping. An electrician can check whether the circuits are sharing a neutral wire and, if so, correct the wiring to eliminate the shared neutral. This can improve the performance and reliability of the GFCI protected circuit. The placement of the GFCI outlet can also be a factor. If the GFCI outlet is located near other electrical devices or appliances, it may be more susceptible to electrical noise or interference that can cause tripping. Try moving the GFCI outlet to a different location, away from other electrical devices, to see if that reduces the frequency of tripping. However, this may not always be feasible, depending on the wiring configuration and the layout of the room. Remember that GFCIs are designed to protect against electrical shock, and their proper functioning is essential for safety. If you're experiencing frequent GFCI tripping, it's important to address the issue promptly to ensure that the electrical system is operating safely and effectively. Do not ignore the problem or try to bypass the GFCI protection. This could put you and others at risk of electrical shock. Furthermore, ensure that any electrical work is performed by a qualified electrician who is familiar with local electrical codes and safety regulations. Working with electricity can be dangerous, and it's important to take the necessary precautions to avoid injury or property damage. By following these troubleshooting steps and considering the various factors that can contribute to GFCI tripping, you can identify the root cause of the problem and implement an effective solution. This will help ensure the safety and reliability of your electrical system and prevent future GFCI tripping issues.